Hello there, and welcome to Slooh. As you can clearly and plainly see, it's a brand new Slooh with a fresh new look, but the same mission, bringing the human response to space directly to your screens. I'm Jerry Montour. I'm your host and expedition leader, and tonight we are turning our attention to defending the planet. That's right. Earlier today, a massive asteroid named 2014 JO25, or as we're calling it, the Rock, passed by planet Earth at a little farther than 4 times the distance to the moon. Now, that might seem far away, but it's the closest an asteroid that large has come in 13 years. We've got our telescopes trained on the rock right now, and for that, we thank and welcome Slooh astronomer Paul Cox. Paul, it's a big one. Just how big is it, and how can we see it?
It's big enough, Jerry, that if it impacted Earth, which it's not going to do, it would leave slightly more than a scratch. This thing, we thought it was only around 600 meters in diameter, but in fact, it's nearly double that. And that was only measured today by the Goldstone radar. But we can see here, tonight for our live streams, Jerry, this is our all-sky camera. This is looking up over the entire sky above our flagship observatory at the Institute of Astrophysics of the Canary Islands. And you can see we have got pristine skies. If ever there was a night to watch the Rock, the big one, whizzing across the sky so close to Earth, I mean, it is a stone's throw in astronomical terms. Tonight is it. And we have got a stack of live streams coming from the telescopes tonight, which we'll take a quick look at.
There we go.
Now, we were saying before the show, we're a little bit nervous. A whole bunch of professional astronomers were getting together last night trying to observe this incredibly fast moving rock. And its apparent speed, Jerry, is so fast because it's so close to Earth. And we were getting nervous tonight before the show. I was thinking, oh no, have I set the telescopes up well enough? And there it is. What we can see here, this is our half-meter telescope. This is our premier instrument that Slooh members use every night. And what we can see there, all the white dots there are stars. They're fixed stars. But the white line is actually during the long exposure that these special cameras take. That is how far the asteroid is moving so quickly in just 60 seconds. And that's why it appears as a long streak. Funnily enough, actually, it is longer than we thought as well, because we saw some radar images of it today, and actually it turns out to be a pretty odd shape. But we've got this image. We've also got the live telescope streams from this one, our wide field telescope, and we also have an ultra wide field view as well, which shows all of the stars around it. And there you can see this is a combination of 2 of those long exposures, Jerry. So on this one, we see the rock as 2 white lines as it's crossing that particular field of stars during those 2 exposures. So pretty exciting. We're really made up that we've actually captured the rock, if you could say that, tonight.
It is pretty neat. For the record, Paul, just how fast is it moving?
Wow, I mean, this one is going at something like 33 meters per second. I mean, that's what, it's over 75,000 miles an hour. And that, Jerry, is why actually even a small rock like the Chelyabinsk meteor, why they can do so much damage. It's their velocity. It's not so much their mass, but it's their velocity and all that energy. Having said that, this thing's going freaking fast, but it's 30 times the size. In fact, it's now we think it's 60 times the size of that Chelyabinsk meteor that gave that airburst and caused all of that damage in Russia in 2013.
And now, how close was it at closest approach, and how close is it now?
About 1 million miles away from Earth. Now, that might sound like a long way. You said at the outset of the show, that's about 4.5 times the distance between the Earth and the Moon. But really, Jerry, in astronomical terms, this is such, I think I said to one journalist, it's a stone's throw. Actually, it's not. It's a rock's throw in this particular case. But in astronomical terms, it doesn't get much closer than this. The last time an object of this size came so close to Earth was one of our other favorite near-Earth asteroids, which is asteroid 2 Tartus. Now, we've covered that twice since Slooh's been around over the last 13, 14 years, when it's made two of its closest approaches as well. It is whizzing away from us, so it's not a million miles anymore. 12 hours ago, it was at a million miles away. It is slightly further away now, but it's still pretty darn close.
Good to hear it's moving away. All right, Paul, thank you so much. Paul will be back a little later on to share with our community just how easy it is to track an asteroid using the brand new Slooh systems. We'll talk in depth about that. Now, Slooh members have been tracking asteroids for years using our telescopes in the Canary Islands and Chile. They've discovered asteroids and helped scientists get a better idea of the position, the size, the speed, and other information surrounding them. And tonight we'll talk about just how important that data is to keeping our planet safe in this cosmic pinball machine, if you will. We'll be speaking with astronomy journalist and author Bob Berman about the way we use telescopes to better understand asteroids and the threat they pose. And he's got some pretty neat calculations for us. Also with J.L. Galash, asteroid astronomer extraordinaire, all about how he and scientists like him keep track of thousands, hundreds of thousands of space rocks flying by and into our planet every day. And that's true. That's all coming up in just a few minutes, so stay with us here on the new Slooh. We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. Hey there, and welcome back to our live show, Tracking the Rock. It's a nearly 1 mile wide asteroid. You can see it right there on your screen as it passes relatively close to Earth. I'm Jerry Monteur. There are a lot of asteroids, a lot flying around in space, and they're all of varying sizes and shapes. And of course, potential dangers to planet Earth. So that's why we care about them. That's why scientists care. But I mean, is this really a big deal? Is there danger? What's it all about? We've got an expert to help us figure all what's happening out here. And Bob Berman is his name. He's an astronomy journalist and author of the book Zoom: The Way Things Move. Bob, welcome to the show. This is a big one, nearly a mile wide. How big is this asteroid, Bob, compared to others?
was very exciting because yes, it's big and it's fast. This is, sure, we were excited by Chelyabinsk back in 2013 on February 5th, but that was only 200 meters across. This is a whole mile, and that was only going 20 kilometers per second. This is 30 kilometers a second. Paul mentioned that speed is very important. It is, Jerry, because the impact forces, the kinetic energy, has to do with the mass times the speed squared. So any change in speed produces a big change, and this thing at 30 kilometers per second. That's about the same speed Earth moves, by the way, through space, 18 miles per second. And the impact forces would be awesome. That's why it's 3 times faster than the moon. The moon is the nearest object, so people into astronomy know that the moon zooms its own width every hour against the background stars. Well, this is moving 3 moon diameters per hour against the background stars of Draco and Coma Berenices. So you bet it's exciting.
Bob, you mentioned the word impact, so I'm going to put you on the spot. Now, thankfully, it's moving away from us, but what if it weren't? What if it were coming directly toward us? How dangerous would it be?
Very, very dangerous. I just did some calculations in the hour before the show. Again, just about a mile across, and given its speed, it would produce an impact equal to 3 million 1 megaton hydrogen bombs. Now that's equal to 200 million Hiroshima type bombs. The bomb that fell in Hiroshima, 200 million atomic bombs. By comparison, the Chelyabinsk explosion, which injured 1,000 people, was equal to 30 Hiroshima bombs. This is 200 million Hiroshima bombs.
So, in other words, game over.
Yeah, game over. And sometimes it really means the new game. You know, the one that hit in the just off the Yucatan coast. 65 thing. The dinosaurs went away, and it paved the way for rats and sitcoms and all the things that we enjoy these days. You know, we wouldn't have that without that great impact 65 billion years ago. So, you know, you never can say for sure it's a bad thing. You know, right now, President Trump is in the news. You bet there'd be different headlines if this thing had a slightly different path.
Yeah, yes. And I'm going to Google sitcoms about rats too, and just see if there's anything out there. Bob, how often do asteroids like this one swing around, something like this size?
Oh, not often at all. For example, the last time we had something to even talk about, Paul was mentioning that was 2004 when we had Tutatis come by, but Tutatis was much smaller. And so this gets the headline. This takes it away from even that. And we know in 2027 where we have maybe one chance in 64,000 of being hit by a meteor, but an asteroid. The reason I say meteor is because anything that hits us is then called a comet, fragment, an asteroid, whatever it was. When it comes in, it's a meteor. So that's why I use that term. But even then in 2027, it's only one chance in 64,000, and it's a smaller object. So this one is a big deal. Thank goodness it's missing us.
So, Bob, how do you characterize this, the potential for a meteor or asteroid impact? Is it concerning to you? Is it simply interesting? Is it fascinating? How would you characterize it?
Well, it's interesting. It's dramatic. I mean, in truth, where are the real dangers? High cholesterol or blood pressure or things like that. I mean, you know, you want to be honest, the chances that we're going to die in this kind of impact. Nonetheless, Discover magazine, back when I was with them in the 1980s and 90s, we carried an article showing that each of us is 6 times more likely to die from an impact from an asteroid or a meteor than we are in a plane crash. Even if we're frequent flyers and we travel a lot, there's 6 times the risk. And that's because even though it's very rare and unlikely. If it does happen, so many people die at once that ups the overall risk.
Yeah, more beer for us too. Bob, thank you so much. As always, incredibly fascinating, and go enjoy your sitcom.
My pleasure. Thanks, Jerry.
All right, Bob Berman. Coming up, how many asteroids are out there, and how would we save our planet if one were headed this way? We'll talk to an expert, and then Paul Cox will be back to show you just how easy it is to track asteroids yourself here on Slooh. So don't go away. Give the gift of the universe. Give the gift of Slooh. A celebration of every magical moment in the night sky. For just $60, you can give the budding space explorer in your life the gift of a full year of Slooh membership. It's available now at slooh.com. And we welcome you back to the new Slooh. I'm your host, Jerry Monteur. Tonight, we are pointing our telescopes toward the skies over the Canary Islands, tracking the rock. And there you can see it in the upper portion of your screen, plain as day. It's a huge asteroid that's flying by our planet closer than any asteroid of its size in more than a decade, and it's almost a mile in diameter. How do we track these asteroids? How is it that information is used to keep the planet safe? Our next guest is an expert in that field. J.L. Galash is an asteroid astronomer, former deputy director of the Minor Planet Center in Cambridge, Massachusetts, and current CEO of Phaethon Engineering. And J.L., welcome to the show. Thanks for joining us. So how many asteroids would you say we are tracking, and what about the big ones like this?
Hi, Jerry. Pleasure to be here. And a small correction, I'm the CTO, not the CEO at Phaethon Engineering.
Beg your pardon?
And no worries. Yeah, currently there are about 16,000, a little over 16,000 near-Earth asteroids that we know of that have been discovered. But of course, there are many millions left. Now, as to how many there are left, it depends on what size you stop counting. There are like if you go to the beach, there are very few pebbles, but lots of small grains. So there are fewer very large asteroids, say of 10-kilometer sizes, and many more smaller sizes down to a meter or so. And for example, this asteroid, the Rock, it's now known to be about 1.3 kilometers in size. So asteroids larger than a kilometer, we expect there to be about 950, 975. And we believe that over about 900 have been discovered. So also all the ones larger than 10 kilometers, which was the size of the asteroid, of the dinosaur killer, those have all been discovered. So we're talking about maybe 80 or so asteroids between a kilometer and 10 kilometers that still remain to be discovered in near-Earth space.
So what's the biggest challenge for you when it comes to tracking asteroids?
Well, the difficulty in tracking asteroids is that they are generally very, very dark. It has been likened to looking for a piece of coal inside a dark mine when the lights are out, because we're looking for asteroids with reflected light, and most asteroids reflect maybe 5 to 10% of the light that comes to them. And that's something similar to freshly laid asphalt, to get an idea of how dark that is. What would give us a leg up is if we were able to look for them in infrared light. And to do this, you have to do it from space. And NASA currently has one telescope called the WISE mission that is looking for asteroids. And there are some plans, hopefully, to fund a new mission, a specifically designed telescope to look for asteroids in the infrared from space. And the other challenge that could be helped looking from space is that we can look into the daylight side of the sky, because currently, as all Slooh members know, you can only use your telescopes at night, which means you're pointing away from the sun. And that leaves at least 30% of the sky on any given day unobserved and unsearched for. So that would be a big blind spot that a space telescope could help patch up.
So, JL, there was a discrepancy in the size of this particular asteroid. It turns out it was larger than we originally thought it was. Why the discrepancy?
Well, one of the ways in which we estimate the size initially is simply by the reflected light that we measure. And this is optical light. And because we don't know how bright the asteroid is, it's very difficult to know with our estimates exactly what the size is. So generally, when we get astrometry, which is just the information that gives us the position of the asteroid in the sky at specific times, you get also a photometry, which tells you how bright that asteroid is at those times. But it tends to not be very good photometry, because most asteroids are found at the limit of the noise. So the surveys are seeing very faint pinpoints of light moving across the image when they find asteroids. So it's these measurements are subject to a large amount of uncertainty. So even though you may give an estimate of the size, say 300 to 1,000 meters, you can be off sometimes, and it turns out that the asteroid is actually larger. And also, this asteroid turned out to be peanut-shaped. And what happens with these asteroids is that they rotate, and if you happen to be observing them, and I have my mobile phone here, which I hope you see. Imagine that this is a peanut. If you happen to be observing it edge on, then you have a very small surface that you're observing. And if you see it like this, then you have a much larger surface. So I suspect that when it was discovered, it was observed, let's say like this. So there was a much smaller surface reflecting light. And that's why the estimates were for a smaller sized asteroids than it actually was.
I see. Now, we've tracked, as you know, we've tracked a few asteroids here at Slooh that were discovered and lost, or were discovered pretty late. Does that happen a lot?
Oh, yeah. You have to think that these asteroids, like I said, they're not necessarily very large in astronomical terms. We're talking of tens of meters most of the time, a few hundred meters, and they're very dark. So when we discover them is because they're flying close to Earth. And in a paper that I published with some colleagues a few years ago, we looked at this when asteroids had been discovered relative to how bright they were with respect to Earth. And we found that probably about a third of asteroids are discovered after they've flown by Earth. But it always happens when they are close, and we tend to discover them when they are at their closest approximation to Earth for a particular decade or so.
Okay, devil's advocate. Let's say we need to deflect a big asteroid to keep us all safe. What are the
Yes.
chances we could do that? What are our options at the moment?
Well, I think you're being more practical than a devil's advocate because it's not a question of if we're ever going to get hit by an asteroid, it's the question of when. And hopefully it's not going to be anytime soon, but this is something that will happen in at least the planet's lifetime, if not our civilization's lifetime. And there are people thinking about this. There are many ideas for deflecting asteroids. Some are, I mean, they go from firing lasers at them to throwing paintballs at them to paint them white, but more serious methods that could actually be applied with today's technology if we put our engineering minds to it are actually three, the three main ones. And in decreasing order or increasing order of power, there would be the gravity tractor, the kinetic impactor, and the nuclear explosion. And I can go through them if you want a little bit.
Sure. This is fascinating. Yeah, go for it.
Yeah. So the gravity tractor is a little bit of what it sounds like. It consists of positioning a craft very close to an asteroid, and there is a gravitational pull between the two objects. So obviously the asteroid being the most massive one of the two would be attracting the spacecraft, but the spacecraft also exerts a little bit of attraction on the asteroid. So if the spacecraft flies very close to the asteroid and gently, very gently moves the asteroid or tries to change its direction using this very slight gravitational pull over the course of many, many years, decades even, it would actually move the asteroid off its current course. Now, this deflection method works only if we discover an impacting asteroid decades before it's going to hit Earth. So it's certainly practical and technologically feasible, but it requires a lot of time. Now, the second approach is the kinetic impactor, which again is what it sounds like. You basically launch a spacecraft and make it as heavy as you can, and you smack into the asteroid and push it. And the push is going to be very small, as you might imagine, because you're crashing a few hundred kilograms or a few thousand kilograms of a spacecraft into many tons of an asteroid. But again, if you impart a small push early enough before the asteroid is going to impact, moving it a little bit now means that a decade or two into the future, it has moved far away enough in its orbit to avoid Earth. And the third and most powerful method is the nuclear explosion. And I always point out that whatever you've seen in the movie Armageddon is not how we would do it. That's Hollywood's interpretation of what you have to do to move an asteroid. And that's not how it would work. We wouldn't actually use a nuclear explosion to destroy the asteroid, because that would be it'd be a little bit silly to try to destroy several thousand tons of asteroid with a nuke. What you actually do is you have the nuke explode near the surface of the asteroid. And what you want to do is push it with the radiation from that explosion. And again, you're trying to push it out of the way so that it avoids Earth. And while these three methods are technically feasible and we do have the technology, none of them have been tested. And they would all require certain finesse in what part of the asteroid orbit you're able to carry them out and where you impart the push. So it would be tricky, but these are things that have been thought about, and there is currently a group called Same Page at the UN that is a group of asteroid scientists and engineers that are looking into the various methods that could be applied to move an asteroid for when the case comes that we actually need to move one.
Sure, sure. So of those three options, which do you think is most feasible and most feasible, say, quickly?
Yeah, quickly, probably the kinetic impactor, because that is something, it's pretty simple. You just need to create a spacecraft and make it as heavy as you can and launch it against an asteroid and hit it, which is not quite as easy as it sounds, because you're trying to hit something that might be a few hundred meters across in the darkness of space. But technically, that is the easiest. The problem with the nukes is that although explosions for the wrong reasons, there is currently a treaty that bans the use of nuclear weapons in the atmosphere and in space. So this couldn't be tested. The kinetic impactor has been tested. There was an impactor launched against a comet I think a decade and a half ago. So this is something that can be tested and probably will be tested again. And it would probably be the simpler solution, most likely to definitely work.
Utterly fascinating and astonishing that this is even being considered. J.L. Galash, founder and CTO of Aten Engineering. And J.L., thank you for joining us. And for my money, I hope someday you are CEO.
I'm not sure I'd want that responsibility. Quite happy with the technical side. Thank you very much, Joe. It's been a pleasure.
Thanks for joining us. All right, coming up, Slooh astronomer Paul Cox rejoins us to tell you how you can track an asteroid just like the rock and help keep the planet safe, all using Slooh's telescopes. So stay with us. We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And we welcome you back to the Slooh, our telescopes in the Canary Islands tracking the rock. It's a massive asteroid thankfully cruising away now from our planet, but it was close enough to make us sit up and take notice for a while. We thank our guests tonight. We now know how important it is to find and track all of these asteroids, and you can actually contribute to this effort as a member of the Slooh community. And we welcome Paul Cox back to the program. Paul, big asteroid, new website, perfect time to tell people, especially people who've been sitting on the fence wondering if they should be a member of Slooh or not. I mean, now's the time to do it, right?
Absolutely. Couldn't be easier. It does take a little bit of work before you can start tracking asteroids and comets. But the great thing about Slooh community is there's loads of people there to teach you how to do it, but it is so simple to actually use the Slooh telescopes. The new interface that we've got makes it incredibly easy. You can just actually reserve a slot, a time slot using the telescopes we've been using tonight. A half-meter telescope. That's a huge telescope for somebody to use. On top of a volcano, 8,000 feet high, world-class observatory site, you can pick from our curated list of 500 of the best objects in the sky. And you can do that with a simple one click. You can also then go in to delve into all of the different catalogues, Jerry. There are loads of kind of astronomical catalogues out there. The most famous one of those is the Messier catalogue, which has about 110 of the very finest objects. So you can go in and you can use those. But if you're wanting to track and monitor asteroids and comets, which are really important, actually we think comets are by far the larger threat. You heard Jose Luis Galash say, oh yeah, we've discovered, you know, all of the big killer asteroids. Well, yeah, we have. But what we're neglecting to put into that situation is our solar system has this vast shell, this Oort cloud full of gigantic comets, and they can come into our part of the solar system from any direction. That's by far the largest threat, and in fact it's comets that a lot of Slooh members get really hooked on, Jerry, to use the telescopes for. And the new interface is going to allow all members to be able to schedule comet missions with the click of a button. You don't even have to know what coordinates they are. As you can see, this asteroid is moving across the background stars. Now, each one of the stars we can see in this image, they stay at the same coordinates all the time, more or less. But you can see this asteroid is moving second by second, so you have to time it quite well. Where is it at that particular moment? That's why I started the show off by really being pretty pleased that we'd managed to capture this one, because the closer they are, the faster they are. So an ideal time to join. It has never been easier, but we actually met Jose Luis Galash at the NASA Asteroid Conference, which we were invited to attend. And it was after that with the help of Slooh members, we developed the Slooh Asteroid Monitoring Program. Tony Evans is a member who runs that for us at the moment. And we've got a full training curriculum if you want to get really, really serious at this and start doing the science that Jose Luis was talking about, measuring their precise position, which helps determine their orbits, which means they don't get lost, like that enormous asteroid Moby Dick that we tried to find when it made its supposed closest approach, but nobody could find the thing. It had just disappeared because nobody had monitored it since its first discovery. So it really is really, really easy. I would just like to pick up on a couple of things, though, that Jose Luis said. The risk of these things, you know, can be enormous. And as Bob said, you know, the statistics of it really show that it's the cataclysmic impact of one of these things that really bumps the statistics up. But I actually made a career before I was doing this astronomy lark of designing and building underground structures for governments. Governments are planning for this stuff. And in fact, only next month, there's a huge conference in Tokyo, which is the 5th Planetary Defense Conference. The conference strapline, Jerry, is Gathering for Impact. They're going to be running a whole bundle of scenarios of a what if an asteroid of this size were to be discovered a year or a month before its impact to Earth. And as Jose Luis was saying there, when we were at that NASA workshop, the only people who could do anything about an asteroid which was discovered late, in other words, within a couple of years even, the only people who were proposing anything that we could do today within that kind of timescale were the Japanese team who arrived, and theirs was that nuclear Armageddon type scenario. That is the only thing we can pull out of the bag at short notice. All of the other things we're talking about, these gravity assist things, these huge solar sails, these painting an asteroid white, we can't do that now. And frankly, those things take such a long time to take effect on that asteroid that you need to discover them at least 10 years out. And we're not doing that, Jerry. And that's why it's so important that not only do we discover these things, but Slooh members, among other amateur astronomers, keep track of them. Our Slooh members are capturing all of these images tonight, and they're going to be taking measurements of its precise location against that backdrop of stars. They're going to be making those submissions to where Jose Luis used to work, the Minor Planet Center. They're doing their bit. So I give a little shout out to everybody else out there who may be concerned about this stuff. There is something practically that you can do. Go out, use the Slooh telescopes to hunt for these things, and probably more importantly, monitor them so we don't lose them.
And help save the planet, Paul.
Literally, literally.
Yeah.
I mean, an object of this size. In fact, when we thought of this object this morning, when we thought it was 600 meters wide, that would cause regional devastation. In other words, it would knock out a continent. Now that we know that it's double that size, right, this really is going to leave more than a scratch. And I think what was interesting from Jose Luis, when he was at the Minor Planet Center, was looking after all of these statistics. And NASA, you'll hear them all the time saying, we found 90% of this size, we've found 10% of this size. Think about what's happened just in the last 12 hours, Jerry. This particular asteroid, which we thought up until today, we had a fairly good idea how big it was. In other words, it was in the 600-meter class of asteroid. This afternoon, this evening, is twice that size. It's 1.2 kilometers wide. Has that actually been applied to that bundle of statistics? Because this is not the first time that an asteroid that Slooh's monitored live on one of these shows has actually turned out to be more than twice the size that scientists originally thought. I wonder if that's being built into those statistics. Have we really found all the big ones?
Paul, I'm going to go grab a shovel as soon as this show is over and start digging. But a great recruitment message for anybody who's sitting out there wondering if they should join Slooh. Not only is it fun, but it might be necessary, Paul.
Absolutely, great fun. And of course, you don't just get to see comets and asteroids, you get to see all the beautiful nebulae and galaxies. We were watching some fabulous images this afternoon, of some of the large galaxies that we can see through the telescopes. And all day, we've had spectacular views of the sun live. We have a very special solar telescope, Jerry, that runs during the day, and we see the sun in this glorious detail. We see these huge filaments and sunspots and prominences coming off the edge. That's been captivating me all day, actually. That's one of the new telescopes that we've launched with the new website.
Well, great stuff, Paul, and yeoman's work as always. Thanks so much. We'll talk to you in a couple of days. All right, you can join the Slooh community right now for free, and you can join a fraternity of space lovers just like yourselves, just as Paul said. Just go to slooh.com and sign up. You'll be able to look through our telescopes, watch all of our shows, check out all of our fascinating community content celebrating the countless human reactions to space, whether you're looking for scientific facts, spiritual reflections, artistic interpretations, or even instructions on how to do all of this yourself. There is something here for everyone. And that will about wrap it up for us here tonight as we track the rock on its close approach as it heads back out to space now. Be sure to reach out to us on Twitter and Facebook. Let us know how you might protect the planet from an asteroid. And as we've heard from all of our guests tonight, it's a real threat. It's got to be. It's not a question of if, it's a question of when. And while you're online, make sure you pop over here to slooh.com and join our community. As you just heard from Paul, there's so much to do, and our brand new interface makes it so much easier to do it all. One thing that is easier than ever, it's watching Slooh's ever-changing schedule of live shows and feeds in the Space Situation Room. In addition to our weekly shows, we also have daily feeds of the moon, the sun, the planets, and tons of other objects in the night sky. On Friday, we'll be sharing a live feed of the Lyrids meteor shower as it reaches its peak. Join us for a night of meteor watching. That is on Friday. Then on Saturday morning, we are celebrating Earth Day, my favorite day of the year, looking live from the International Space Station down on our little blue planet. We'll have some very special guests, including a couple of real-life astronauts who will tell us what they missed about our planet while they were up in space. And we'll hear directly from members of our community to find out what all of you would miss most if you had to leave. That starts Saturday at 9 a.m. Eastern Time. We hope to see you there. But until then, I'm Jerry Montour. Thanks for stopping by. Thanks for watching Slooh, Space for Everyone. Hello there, and welcome to Slooh. As you can clearly and plainly see, it's a brand new Slooh with a fresh new look, but the same mission, bringing the human response to space directly to your screens. I'm Jerry Montour. I'm your host and expedition leader, and tonight we are turning our attention to defending the planet. That's right. Earlier today, a massive asteroid named 2014 JO25, or as we're calling it, the Rock, passed by planet Earth at a little farther than 4 times the distance to the moon. Now, that might seem far away, but it's the closest an asteroid that large has come in 13 years. We've got our telescopes trained on the rock right now, and for that, we thank and welcome Slooh astronomer Paul Cox. Paul, it's a big one. Just how big is it, and how can we see it?
It's big enough, Jerry, that if it impacted Earth, which it's not going to do, it would leave slightly more than a scratch. This thing, we thought it was only around 600 meters in diameter, but in fact, it's nearly double that. And that was only measured today by the Goldstone radar. But we can see here, tonight for our live streams, Jerry, this is our all-sky camera. This is looking up over the entire sky above our flagship observatory at the Institute of Astrophysics wide field view as well, which shows all of the stars around it. And there you can see this is a combination of 2 of those long exposures, Jerry. So on this one, we see the rock as 2 white lines as it's crossing that particular field of stars during those 2 exposures. So pretty exciting. We're really made up that we've actually captured the rock, if you could say that tonight.
It is pretty neat. For the record, Paul, just how fast is it moving?
Wow, I mean, this one is going at something like 33 meters per second. I mean, that's what, it's over 75,000 miles an hour. And that, Jerry, is why actually even a small rock like the Chelyabinsk meteor, why they can do so much damage. It's their velocity. It's not so much their mass, but it's their velocity and all that energy. Having said that, this thing's going freaking fast, but it's 30 times the size. In fact, it's now we think it's 60 times the size of that Chelyabinsk meteor that gave that airburst and caused all of that damage in Russia in 2013.
And now, how close was it at closest approach, and how close is it now?
About 1 million miles away from Earth. Now, that might sound like a long way. You said at the outset of the show, that's about 4 times, 4.5 times the distance between the Earth and the moon. moon. But really, Jerry, in astronomical terms, this is such, I think I said to one journalist, it's a stone's throw. Actually, it's not. It's a rock's throw in this particular case. But in astronomical terms, it doesn't get much closer than this. The last time an object of this size came so close to Earth was one of our other favorite near-Earth asteroids, which is asteroid 2 Tartus. Now, we've covered that twice since Slooh's been around over the last 13, 14 years, when it's made two of its closest approaches as well. It is whizzing away from us, so it's not a million miles anymore. 12 hours ago, it was at a million miles away. It is slightly further away now, but it's still pretty darn close.
Good to hear it's moving away. All right, Paul, thank you so much. Paul will be back a little later on to share with our community just how easy it is to track an asteroid using the brand new Slooh systems. We'll talk in depth about that. Now, Slooh members have been tracking asteroids for years using our telescopes in the Canary Islands and Chile. They've discovered asteroids and helped scientists get a better idea of the position, the size, the speed, and other information surrounding them. And tonight we'll talk about just how important that data is to keeping our planet safe in this cosmic pinball machine, if you will. We'll be speaking with astronomy journalist and author Bob Berman about the way we use telescopes to better understand
physics of the Canary Islands. And you can see we have got pristine skies. If ever there was a night to watch the rock, the big one, whizzing across the sky so close to Earth. I mean, it is a stone's throw in astronomical terms. Tonight is it. And we have got a stack of live streams coming from the telescopes tonight, which we'll take a quick look at.
There we go.
Now, we were saying before the show, we're a little bit nervous. A whole bunch of professional astronomers were getting together last night trying to observe this incredibly fast moving rock. And its apparent speed, Jerry, is so fast because it's so close to Earth. And we were getting nervous tonight before the show. I was thinking, oh no, have I set the telescopes up well enough? And there it is. What we can see here, this is our half-meter telescope. This is our premier instrument that Slooh members use every night. And what we can see there, all the white dots there are stars. They're fixed stars. But the white line is actually during the long exposure that these special cameras take. That is how far the asteroid is moving so quickly in just 60 seconds. And that's why it appears as a long streak. Funny enough, actually, it is longer than we thought as well, because we saw some radar images of it today, and actually it turns out to be a pretty odd shape. But we've got this image. We've also got the live telescope streams from this one, our wide field telescope, and we also have an ultra